Okay, now comes the most important part. This is what is going to be really, really helping you in doing everything, whether it is the quiz or the assignments or anything. Okay, so let's take a look at this carefully. I hope you remember doing like, words, and even in English, where, where you have to combine two things and it makes one thing, like cornflakes, like that. So stuff like that, where you are adding two different words to make this single word. This one, you have to remember that there is always a prefix and there is always a suffix. And we are going to talk about each one of them separately, along with examples. More examples than what you've seen in the PowerPoint, and then I'll share them with you in the Canvas. Okay. So the most, the example that's given here, let's just start with that. 4-carbon acid. 4-carbon is a keyword here. Acid is the other keyword here. Okay. In the second one, 3-carbon aldehyde. So 3-carbon is the prefix. Aldehyde is the suffix. Okay. How does this work? So the first thing is you have to remember all the prefix. So for example, 1 is for methane, 2 is for ethane, 3 is for propane, 4 is for butane, and so on and so forth. Okay. So if you see here, these represent the number of carbons. So usually it's, if you remember the first 4, the 5th one onwards is easier for you. So my question to you is, do these prefix confuse you?
Yes, I don't understand this part at all.
Yeah.
Okay. Okay. So if you see here, I think what will make it easier is if I make another little chart here. So I will say here that 1 carbon is methane. Okay, this is not going to be like, okay, 2 carbon is ethane, 3 carbon is propane, 4 carbon is butane. So now I'm going to show you what do I mean by that. Okay, so which means that if I was to make here C with it's kind of hard to make. Okay, C with 4H, then I would end up with a 1 carbon structure, and that 1 carbon structure would always start with meth or methane or methyl, meth as the prefix or the beginning of the word. Let us see one more example. One more example would be, what about ethane? So when we talk about ethane, we're going to start with 2 C's. 1 C, 1 C and 2 C. So if you see 2 C, that is a methane. If you see 3 C's, or if someone says, what is a 3-carbon structure, which is an acid or alcohol or whatever, that is propane. And then you have the 4-carbon, that is the butane. So all I mean to say is the number of carbons mark the beginning of the word. Is that part clear or not clear? And where is the confusion? If you can ask me more questions, I can help you.
I understand it now.
Okay. So anytime someone says butanol, you're going to go back to this chart and say, what does this butane part mean? Oh, it means 4. So if you can just remember these, like the first one is C, 1 is C, 2 C's is ethane, first one is methane, 2 C's is ethane, 3 is propane, and 4 is butane. Then it solves the initial or the prefix part of the word. Okay, and that's why I said the pentane is easier. Why? Because we know that when we talk about pentane, we know that a pentane would be pentagon is for 5. Okay, so we know that this must be for 5 carbons. Similarly, the next one is for 6 carbons. See, if when you share like this, it really helps me also, because in the sense I can update this and make it even more understandable in the sense like I can include this information and this will help you even further. Okay.
So it's like no matter what so you don't pay attention to the hydrogen, it's more so just the carbon. And um whatever number it's sit next to tells you the prefix name.
Exactly.
Okay.
Very well put, China. You said the number of carbons is what decides the prefix. Yes, it has nothing to do with hydrogen. Absolutely. Why
Okay.
is the hydrogen mentioned here? Because this is the alkane, and maybe you can have a better table. I can remove all this, but the thing is that what happens is that methane can sometimes be methyl. So that is why I just want to, I just included the alkane names. But yes, you're absolutely right. Number of carbons is equal to the prefix. Easy.
Okay.
Done. Now that this part is clear to us, what we are going to do is go to the next part, and we can come back here. There is no stopping like that. Once we leave this slide, then we cannot visit this. Now that we know this part, we are going to go to the next part. Now comes the end. You know it is methane, but what is it? It's methanol. Is it methanoic acid? Is it methanamine? Is it what is it? So the end part is decided by what we call a functional group. Whenever I am using the word functional group, I am seeing there is a little bit of question mark and confusion. So I want to clarify that the functional groups are written in red here. For example, OH is a functional group, which signifies alcohol. And whenever you name an alcohol like methanol, butanol, propanol, you end it with an ol. So functional group is the one that is adding the function to that chain of hydrocarbon. And where is the chain? That is R. R is the side chain here and or the chain here, and the OH is the functional group, which is the suffix. So chloride, okay, or we can say chloromethane. That we'll come to that one later. That's why I've not mentioned this one here. It can be an ether. It could be an acid like butanoic acid, propanoic acid. So propane should tell you 3. Oic acid should tell you, I need to put a COOH. So the first part you refer here. Second part you refer here. So when I say, I'm going to draw a structure for you and show you. So let us say, if I say butanoic acid, first of all, you're going to say, I'm going to take care. I have 2 parts to take care of here. My first part is this part, and the second part is this part. So let me take care of the first part first. Butane, 4. 1, 2, 3, 4. Done. Oic acid, COH. Okay, I don't want to increase the number of O's in here because there are already 4. So what I'm going to do here, OOH. Okay. So did you see how I made the structure? Now many of you may question and say that, oh, what happened to the H? Right? So you need to put all the H, and I'm going to just put the H by putting the star here. So how many H does the first carbon require?
3.
How many one this one needs?
2.
And the third one?
2.
Okay, and the last one actually does not need anything. I know at this moment it looks to you like it needs something, but when we go to the slide, you will see this C double bond OH actually looks like this. I'll try to draw it. It's not this too, but C double bond O OH.
So how come the fourth C doesn't need anything?
Yeah, I'm showing you. That's exactly what I'm showing to you. I'm showing to you that the fourth C is actually, yeah, fourth
Is it double bonded?
is because there's double bond with O and a single bond with another O. So do you see how this C double bond OH actually looks like? It has 2 bonds with O, accounting for 2 bonds, one with OH, number 3, one with C, number 4. It does not need anything. Let me show this to you. Don't worry, I know it can be confusing. Let's go back, just go to the acid structure. Do you see this? Not this, sorry. Not this. Oh, right here. Do you see this?
Yeah.
Already has 4 bonds, as a result of which it does not need an additional hydrogen out there. Also, I want to remind you, just like carbon loves 4, for the carbon, the magic number of electrons is 4. For oxygen, it's 2. Do you see here how each of the oxygen has also filled their own agendas of having 2 bonds? One oxygen has a double bond, one has one with carbon, one with hydrogen. And the hydrogen always fulfills its agenda by combining with another atom, just one bond. So essentially, it's all a matter of filling the bonds. And that's the reason why we started with that whole orbital story, just to remind you, this is how it works. So again, if someone said to you ethanoic acid, first thing, ask yourself, what is the prefix? Ethane. Oh, okay, so 2 carbon. What is the acid? COOH. Oh, let me draw that. Fill the rest with the hydrogen. Does it make sense?
Yes, but then I'm still trying to figure out. It's like I just figure out how to do like the prefix and the suffix, and then now I'm confused with this part.
Okay. Yeah. Oh, yeah. I know. I see what you're saying. Okay. So let's give it a better start here, so it helps you. So we're going to start with this one. You can see this is very simple. There are no functional groups in alkanes, so we are pretty chill. We don't need to worry about what is the end, because we know that there is no end. So it has just single bonds. And also for your convenience, you have ball and stick models here, so that you can see how balls, the black balls are carbons and the gray balls are hydrogen. Okay, so how they are combined, and they form the methane and the ethane respectively, and the propane. Are there any questions on this slide about the alkane? Or is it okay? Like anything that is confusing here? Nothing? Or
Can you give us an example of a 4-carbon chain using the an amide attached to it?
Oh yeah. I mean, you mean the ball and stick model, or this just the structure?
Structural, please.
Okay, sure, why not? So here we have, let's see. It may not be, let me make this black. Okay, so this is 4, okay? Now let's draw the remaining. So whenever I have to draw the remaining, I'm going to use a red one, okay, make it easy. This carbon has 2 bonds already, which I made 2 bonds. It actually had only 1 bond. Let's see, this one should be a hydrogen. Okay, this carbon has 1 bond, so 3 hydrogen. This carbon already has 2 bonds there, because the inner one has to combine with 2 carbons, so 2 more. This has already 2, so this comes here. And the last one, these have 3. Okay, so which means that we can fill the rest with the hydrogen. So, it's not easiest to do it over here, but we can try. Hydrogen, and then oops, one more. And maybe you can't see the bottom, but I'll still make it 1, 2, 3, 4. I hope you can. Do you see that there? This is the 4 carbon with all hydrogens. And what is this called?
Is that butane?
Yes. Absolutely. This is butane. Is that okay, everyone?
Can you add an amine to that butane, please?
You're saying, could I add an amine to the same or one of these, the butane structure?
Yes, please.
I can do that. I hope people don't get confused because they can get confused. Okay. So yeah, I mean, if it's butanamine, then oops. And what about if it is butanol?
It would have the functional group with the OH, right?
OH, yes. And
That's
it will
it.
be OL at the end, like when
That's
it's
right.
ethylene.
Absolutely.
Thank you.
So all you are doing is you're keeping this constant, but when you're doing acid, be careful because you know you want to you want to make the carbon numbers acid or aldehyde. You want to keep the carbon numbers same. Always 4 is the butane kind of structure. Okay, always 4. So let me clear this and go to alkene. Okay, so then I have this alkene. The last time what happened is the structure I showed, there was some problem. So I just, I'm just showing you again. So ethene and propene. So if you see here and, guys, I know this is very bothering that sometimes they show the H like that, like diagonal, sometimes they show like that, but don't worry about it. It's just the number of hydrogen that matter. So this is ethene. In older chemistry, they call it ethylene, which is fine. We're just getting familiar with these terms. This is propene and this is butene. I wanted to show you that there can be 1 butene when the double bond is at 1, and there can be 2 butene when the double bond is at 2. Now you may say, why are you again confusing us? I just want to tell you that the position of the double bond is something that you should also, is something that you may also find sometimes mentioned in the structure, okay? And the reason we are not doing too much details of this is because you are studying a 2-credit biochemistry class, which means that I'm not really supposed to go into too much detail, but I'm just sharing with you that a butene can have double bond at 1 position, 2, or 3 position. It can have it anywhere, okay? Which means that first carbon is called position 1, second is position 2, and third is position 3. So now in this one, again, if you see here, this is a double bond, so it needs only 2 hydrogen. This is a double bond here and a single bond here, so 3, so needs only 1 hydrogen. And these are regular single bonds, so this needs 2, and this needs 3. So a butene is a but, which is 4, with a ene, which is a double bond. So again, the suffix here is ene, that stands for alkene. And a very similar thing over here, this is ethyne, propyne, and butane. You can see methine is missing because methine has no, it has only 1 carbon. So if you see here, there are triple bonds in here at each, and the remaining have the hydrogen. The remaining are the hydrogen. Is that okay? Are there any questions? Yeah, sorry.
So can you show one more with say you were doing amine or like another board like acid?
Yeah, I'm getting there. I want to make sure that I'm on the right side. Good question. Okay. So methanol, again, whenever I see methanol, I'm telling to myself, and I encourage you to do the same thing. You tell yourself 2 parts, methane part, all part. I'm going to break it down. When I say ethanol, break it down. When I see propanol and someone says 3 carbon, that's how I make it. I break down the prefix and suffix. Okay, 1 carbon, I put the functional group OH, the rest I filled up with hydrogen. Same thing I do here. This is like the quick and easy way. You put the 2 carbon here for ethane, 1 OH here for all, and the remaining you fill up with hydrogen. And the similar thing you do in propanol. Okay. So, and that's what is typically used a lot. And, when you go to, your fields, it will be used a lot of ethanol related for disinfectants and degerming. Okay, aldehydes. What happens in case of aldehyde? It comes with a C group. So be careful when someone says ethanol, that CHO has to be included within the structure. Again, I'm not going to be scared when I see the structure. I'm going to be like, this is ethane. I know that's 2. Al, that is aldehyde. That means I make a 2-carbon compound, and then in that hydrocarbon, I add a CHO group, and the rest I fill with H. Does that make sense?
Yes.
So, the O with the electrons, I forgot about that one already.
Okay. Don't worry about it. Look at this one. I know this O doesn't look nice. I know this O looks confusing. Don't look at O. O is taken care of itself. O needs only 2 electrons, so it has taken care of itself. Okay. So don't look at that red O. Look at only the black O. And it's just that C has double bond with O and single bond with H. And you don't have to draw that. When you draw like this, okay? You can just say C with a CHO. So you are not worrying about who has a double bond and who has a single bond if that's something you don't want to worry about, okay? And then you can draw the remaining H, which one will come over here, here, and here. That's it. That's why it becomes CH3, CHO. Is that okay?
Yes.
Okay, so yeah, don't worry about that. I know that can be confusing. But here is the thing. I always believe that provide a little bit extra information, because eventually you will understand this. Instead of like hiding all the information from you, let you have the information and ask me questions. Okay, so similarly, we have here a ketone. Now you may say, like, already by now you have read so many functional group, it gets confusing. Look at that. This one has a functional group in the end. CHO is in the end. And this one has in the middle. C double bond O is in the middle. And that's a ketone. How do you say a ketone? You have butane with a on. That was butane with the ul. Butanol. This is butanon. So like I was suggesting last time, I would just like print out or draw these, like the suffix chart, and keep it in front of me so that whenever I need to refer, I'll go back and keep referring to that chart. I highly, highly encourage you to do that, at least for the first half of the semester. Have the suffix chart put in front of you, even prefix chart put in front of you wherever you're studying, on the notebook or somewhere where you do your work, and keep it handy so that you can refer anytime. So that's for ketone. Then there is acid. So, you have to remember these, what we call functional groups. So ethanoic acid, butanoic acid, propanoic acid. Again, don't look at the O if it is confusing you, because we don't need to have these, take a look at these things. What I can do for now is I can just, see, I hid it for you. For anyone who did not like the things, you see? Yeah, now much better? Okay. So, just saying that this is the ethanoic acid. It has 2 carbons and an acid formula, the acid functional group at the end. Okay, similarly for esters, okay? So for esters, you are going to label it. Sorry, this looks like I did something last time. So you're going to label it. Oops. You're going to number it like this. First of all, you're going to talk about the smaller side. It has only 1. This is methyl group. It's only 1. So whenever you have to name 2, you pick the smaller one first and then the larger one. Methyl ethanoate. Its oite is the sub methyl ethanoate. Okay. So if it is instead of ethane, it was propane, you will say methyl propanoid. So this one is a little bit difficult. I would admit that it is a little bit tricky because, but it's not frequently asked so much. So I wouldn't worry so much about it. I would worry right now about how to understand the concept of having the prefix and suffix.
So this is just combining, oh, sorry, if you go back, it's just basically combining the two and then making it like one into one thing.
Yeah. And that's a really good question. You know why? Because you may say, why is it not propanoid? Because it has 3 carbons. But you see the propane chain is broken in the middle with an O. So you cannot call it 3. You have to have the 1 separate and then the 2 separate.
Okay.
That's what the thing is. So that's why it is methyl ethanoid. And like I said, in this one, I wouldn't ask any difficult questions because it already looks a little like complicated. Okay, so in this one, this is an ether. And if you see this, this is also having a break in the carbon chain. Whenever there is a break in the carbon chain, you have to count this separately, right side separately, left side separately. Because the nomenclature system doesn't allow you to just call it as a butane something. It's not, it is CCOCO, which means that there is, these 2 C's are separate, that is ethyl. These 2 C's are separate, that is ethyl. So what you call it is diethyl ether.
No, but it's a formula.
Okay. All right. Now look on that on this side again. Those ball and okay. So again, you look on this side. You see these black balls. These are carbon. The gray ones are hydrogens, and the red one is oxygen. And what do you call this? This is a skeletal structure. So I just want to introduce this to you. Why? You may think that things getting a little crazy. No, don't worry. Because wherever you see this end without any name, that is C, always. Sorry, some of my C's are big and others are small. But that's what it is. These 3 structures represent the exact same thing. Are you guys ready to do some examples, or you are we can, I have collected a lot of examples for you to try out.
I have a question.
Yes.
Would you take off if we don't indicate the missing bonds on the oxygen? Or something?
You said, would you take points off if we do not indicate what?
The missing bonds on the oxygen. If we don't.
Good question. Actually, you won't have such, like, I typically wouldn't ask you to draw an ether. I feel like you should just stick to things which have, because I feel like this could get a little bit confusing,
So leave it as is or don't?
Yeah, so I mean, I would ask you to name things, but not like draw things.
Okay.
Yeah.
Thank you.
So
That was
What do you say? You say you're gonna ask us to name them? Sorry, I
name
didn't.
things. Yeah, name things. Like, I given a structure, name it. Then you
Okay. So we just count the carbons, and if you have a O on a COOH or versus, okay. Thank you.
Yeah. For especially for ether-like things, which are like harder to draw, I would just stick to more like, can you name this rather than can you draw this?
I had a question too, Professor. So
Yes.
okay. So when do you know once you put the electrons with the O? Because like with this sample, there's no electrons on the O.
Oh, don't put any electrons ever with the O.
Okay.
Yeah, just keep it simple. O should have 2, carbon should have 4, hydrogen should have 1. That's it. Those are the rules we go by. And some of the figures that I picked, not every figure was made by me. Some of the figures that I picked just happened to have that electrons, and I did not realize it could be confusing. So I would remove them. But for your reference for now, don't think about the electrons.
Okay.
Good question. All good questions. Okay, so amine is not very different from ethanol, like alls, because it's just an NH2 in the end. And I did change this picture because it was confusing people. And you have a question which is like 5 carbon amine. So, I mean, it's not that hard. You say put the 5 carbons, what is that prefix? You put the amine in the end, and that's what it is. So So for that assignment question, please make sure that you draw structures for all, because it does have space and I guess the expectation for a structure. Amide. Okay, amide is CONH2. Again, this is, I think, one of the last ones that is like more difficult ones. And why is it called acetamide? Because this is the older name. Actually, you can call it, let me write it here. This is ethanamide, this is hexanamide, like that. So again, it is, finally, it comes down to, can you find the prefix and the suffix and then just put them together?
Are we going to be responsible for knowing the, I guess, the new name of those?
New name only, no old names will be needed.
Okay.
Only numbering system is the one that is needed. Okay, I want to stop sharing this. I want to challenge you to something a little bit different, okay? I want to show you the exercise that I got for you. Let me see. It's right here. Why am I not seeing this? Oh, right here. Okay, all right. This is a test for, wait a minute. Oops, why did that happen? No, can't believe this. Sorry, PowerPoint kind of took over. Okay, I'm excited. I want to see how many of you can do this, and then it will help me also understand where we are going, right? And so I kind of hid the answers. Okay, so if you want, you can write in the chat. If you want, you can practice or whatever, but I kept it kind of easy. Okay, what is the first structural formula on the right side? And I'm going to explain you more, or maybe I can just do the first one with you. So if you see here, it has 4 C's. You have to identify what is the prefix. Prefix will be identified by C's, and suffix will be identified by the functional group. Identify the prefix, identify the suffix, that goes in. Okay. Now, about, okay. If you are asking a question, good. Otherwise, try to keep yourself on mute. Okay. So about the formula, you're just counting the number of C's and putting here, counting the number of H and putting them here. Also, you can put down the formula as CH3, CH2, CH2, CH3. If you do this, guys, together, you'll find this to be something which will really, really help your understanding. So the first one, I want to.
Excuse me. Can I ask you something?
Yes.
So like, and then the CH2s are together. So I was looking at something on YouTube earlier.
Mm-hmm.
Could you put those into parentheses?
You can, yeah.
Okay, but you can't put the CH3 into parentheses because they're not together, right? Because they're not aligned side by side.
Yes, you're right. Yeah.
Okay, so you would so say CH3 parentheses CH2
Twice.
close parentheses and then put a 2 and then CH3.
You can do that, but for others who don't know the system, and if you don't want to do it this way, disregard our conversation. Is that okay?
Right.
You can do it this way, and I would never take off your points for anything right you do. And if in future you do an exam, you feel like I did this right and I took off your points, show me and I will give you points. Okay, show me that you learned from somewhere else. That's okay. You can learn from anywhere. It didn't have to be my PowerPoints. Okay, so second one. Who can tell what is this particular thing? And you can just write on the chat, or you can write it to me. I don't know what works. I'm just trying to make sure that everyone understands, so you can unmute and say, and you can question each other or whatever. What is it? What is the name of this particular compound? And right now we are doing.
Is it a butanol?
Right now we are doing this one.
Can we go back to the first one? Because how did we get that?
Yeah, is it butanol?
How did we get the first one?
Yeah.
I mean, which part of it is not clear?
The whole thing. Like you put the name in there. So I know you have butane in there. So
but
is this for
Yeah, disregard the N, butane. That's it. Do you see what I'm saying, Shai? It's okay, right, if we disregard the N? Sense to you?
okay? So are you talking about is the formula and the structural formula all
No,
supposed to
I'm
be-
just talking about the name now. Let's start with the name. I want to know what is, in your opinion, what is the name?
So which
You
part
can-
are we looking about? Are we talking about the formula? Am I looking in that box or am I looking under the structural formula?
Okay, there is only one way to find this out, by looking on the right side box. Okay,
Okay.
for these.
Okay, so we're working on the second one. We're working on the next one that you're circling. Okay, because I was at the first one.
Okay, for the second one,
So the second one be
butanol. Does
butanol,
anyone
right?
have a different answer than butanol? Sorry if I interrupted you. Does anyone have a different answer? Okay, so butanol would be just fine. I wrote 3-butanol just to show you that the position is 1, 2, 3, 3-butanol. Okay, but butanol by it.
I see 4.
Yeah, I thought it
See
was four.
1, 2, 3, 4. And
Right.
then I see the alcohol. I see the alcohol, but I see 4 in there. I don't see 3, sorry.
Yeah, I thought it was
Is the
four.
position of the OH group? At what position is the OH group? 1,
On top.
2, 3. We are talking about this one, right? Let's all talk about only this one. Let me.
What about the CH3 at the end?
Yeah, I mean, I'm counting that. That's why it is butanol. But where is the functional group? Where is the functional group? Is it at position number 1, carbon 1, carbon 2, carbon 3, or carbon
Three.
4?
3.
That is why I put 3-butanol, because
Oh, okay. I understand what you're saying now. Okay,
Okay.
I didn't quite understand at the end. Okay.
okay, so in your opinion, what is this? Like that was C4H10. What would be this? And you guys can all do it in your own notebooks. But someone has to tell me. I cannot write it by myself. Is C4 and then what?
H10.
Is it C3H6?
C4
C4H10.
H what? C4. Okay, so we still have 4 C's. C is 1 is here, 2, 3, and 4. So 4 C's, and how many H? You just have to count the numbers, like literally.
C4H10.
And then how many O's?
1.
1.
That's it. Let's break it down and write it. CH3. I'm going to do it only for 1. I'm not writing it very nicely. I know that because of the format of this thing. The 3, the number should be in the bottom. It should be, it should not be like with the regular things. Okay. I want to go to the next one just because, there's so much time. Okay, so for the next one, what do you think the name of the next compound is? And of course, if you have a question about 2, we can still discuss. Does anyone have questions about the butanol one?
Yes, Professor. So I missed that part when you was talking about the groups. So if it was like if the OH would have been on the last CH, that would have made it 4-butanol.
Yeah, but you don't usually write 4 because it's kind of obvious. Like when it's in the end, you don't write anything. You just say butanol.
Okay.
And for you guys' reference, unless I specifically asked, if you just wrote butanol, you would still get 100% mask. Unless I asked you, like, what is this particular thing? And again, this is not to like make it harder. This is just the accepted terminology in the, in the chemistry world. So just making you familiar, but we are not going to emphasize too much on it. I want you to know it, but not be like, oh my gosh, if I don't know this, something is going to happen. No, you're going to learn this probably in future too, but just learn how it is done. Okay, so the second one.
That should be a butane. It has a 4-carbon chain.
Okay, you said butane.
Yes.
Okay, anyone else?
So we still have to put the suffix to it, right?
Yes.
I say it's a double bond.
Okay, good.
Is it a butene?
Okay, that I agree with
So-
that.
Yes, and it's a double and it's a 4 in there. So
Yeah, you can say butene, and I mean, if you were really up to it, then you could say 2-butene, but you don't have to. Like I said, you don't have to, but I'm just showing you how it is done as we go. Okay, and again in here, what would be that magic number after C? That is C4, and then how many H?
8.
That's it, done. And then if you were to write it down, you could write it down as CH3, CH, CH, and CH3. The thing is that if I write like that, anyone can make the structure again. They know like what exactly I'm talking about. Let's do the next one.
quick question. The only part I do get confused about that is the number 2. Shouldn't it be 3 because it's on top? Sorry, it's on top of it. That's the part I did get confused for number 2.
Or you mean the 2-butene?
Yeah, I do understand why the name, but why the number 2? I didn't get it.
Why the number 2? Because it's the double bond starts at carbon 2.
Oh, okay. Because upstairs was on the 3, so I thought this one would be 3 as well. 3-butene.
Yeah, I know it feels like it is between 2 and 3, but it starts at 2.
Oh, okay. Just when it's double bond, right?
Yeah.
Okay, thank you.
Okay, the next one. What is the next one? I know the time is a little above 3:30. I mean, people who want to stay and do, I don't think it will be more than 10, 15 minutes, but just,
It's with the Y because it's a 3. And
yeah, I mean, let me circle this. Let me circle. We are doing this one now. Like finding new ways to.
A propane. Well, yeah, it's a propane.
For some stupid reason, I cannot access chat. It's so annoying. God. Okay, some people are writing answers. Okay. I see. Okay. So it is a continuous carbon chain, which means it has to be 4 carbons, right? Do you see anything special? I see 3 bonds. So what can I call this? Oh, okay.
It would be, never mind, I don't know.
No, you were on the right track, man. You should do
butyl, it's with the Y.
That's
butane.
Yeah, butane.
But I know have a Y because of the triple bonds will be with the Y. So it will be with the Y instead of the
Butane. Okay, good.
Yes.
Oops, this is nice. Let's do this next one. Okay. What about this one? What would you call this? Since this is a little bit difficult, why don't I show this answer to you? So this is 1,3-butadiene. I would not typically ask this kind of question, but just for you to understand, I want to always you to go above and beyond. I want to make sure you understand there are 2 enes. So I call it 1,3-butadiene. Why do I call that? Because at position 1 of the carbon, there is 1 double bond, 2, 3. At the position 3 of the carbon, there is another double bond. So 1,3-butadiene. Okay. So don't think too much of this example. I'm just trying to, I picked it from somewhere and I felt like it would be a nice idea to discuss. Okay, this one.
Is it butene?
butene.
Butene is perfectly fine. Butene is perfectly fine. I know you must be thinking, why is everything butene? I
So-
just wanted to tell you that just for your reminder, this is also cis and trans. Cis is on the same side. So if you like saw somewhere cis butene, please don't get confused and think we never learned this. Cis means the structure, these groups, these two groups, which are not a part of this, they are on the same side. And on the same logic, this is actually, this is not. Okay. Yeah, okay. So what is this? Now don't, I should say that, look at this structure. It has CCOC. It should have been drawn straight. If it was drawn straight, it would look like this. C. Okay. And then the H3s. What would you call this? First of all, pick the smaller one. And what is the, when it is not used as a name, what is the methane group called? You remember? Methyl. You remember that part? Does anyone remember? Okay, I just don't remember. Let's see. So do you see that there is in this one, in the ethers, what happen is that it is methyl is one side, ethyl is one side, and then you just call it ether. Methyl, ethyl, ether.
Professor,
Yes.
so do we need to mention like there are two methyls, one on the left, one on the right side? So do we need to say like,
Actually, there are not two methyl. This is methyl. I know you are talking to this methyl, talking about this methyl, but it is attached to CH2. It is attached to CH2. So that means that it is going to be more like ethyl, or, you know, that it's not a methyl. You know what I'm saying? It's a great point, but I will have to say that this is actually like this, and this is like this.
okay, so the methyl is referring to the one on the right side.
Right, exactly. The smaller one comes first, the larger number of carbons come later, and then comes the word ether. Okay, let's do this one, guys. This is easy. This should,
Excuse me.
yes.
Is it okay to refer to it as dimethyl, ethyl ether?
Not really, because, you know, this is methyl is only one side, and the second one is C2, like 2 carbons. If it was, if we were doing CH3O, CH3, then yes. Unfortunately, this is not that structure. This one is CH3 on one side, but the CH3, CH2 on the other side. That is why it is supposed to be methyl on one side and ethyl on the other side.
Thank you.
Okay. Okay, how about this one? The next one should be really easy. I know there were some confusing ones, but this one is really easy. The reason is that you have to recognize here. So 3 carbons. So what does it start with?
Propanol to the pro.
Okay, and then this one is CHO. What is CHO? You can look back at, sorry, aldehyde, yes. So then what will be the name? Propanol. Is that okay, everyone? Is that okay, guys?
Yes.
So the one over top of that, the one that you previously had done. So I'm kind of confused. So that has 3 carbons as well. I mean, how come that isn't?
Because it's broken. The chain is broken with an oxygen. Whenever the chain is broken in between with an oxygen,
Oh, okay, I see.
it's a 3 carbon chain.
Oh, okay.
Very good question. Very good question. And this question is always, this is like for ages, this confuses people. So just telling you, whenever the carbon chain is broken, you never count it continuously. Here there is an O in between, and you have to take into consideration that O. Okay, what about this? What is this? C double bond O, what is that particular functional group? We all know 4 is what?
Ketone.
Ketone, perfect. So what should this
Yes.
be?
It would be bution.
Almost there, yes, butanol, yes. Yeah, butanol, that's right. Butanol, and like I said, you can ignore the number. Butanol is just fine. Okay. Okay, next one, what is that? Let's do this quickly now that you're in the swing of things.
Does that one have 2 functional groups?
Does that one have, sorry, what? Say that again.
Does it have 2 functional groups? The OH and the C.
Oh, no. Oh, good question. Well, there is only one functional group. I hope you can recognize it has a COOH.
Yeah, so it would be a meth.
It's an acid. I'm
It's
sorry.
good, very good. Acid. Two carbon acid. What can be a 2 carbon acid? What is 2 carbon?
It's ethane.
Okay. Is that okay?
Yes.
Does that make sense? Okay.
Yes, that makes sense.
Okay. Okay, next one. If you want to skip the next one and do that one after that, you can do that, because the next one, I know it will take time because it has a break in the chain. So you consider one part of the chain separately, the smaller one first, and then the larger one. So you can simultaneously, for us to finish, you can tell the other answers. I'm going to just number them. Are you telling me number 1 or telling me number 2?
So it's 2 again.
Say that again.
It's 2 again. 2 separate groups.
This one has only one functional group, and that's a COO again. So you have to remember that you have to recognize the functional group. This is a COO. This is OH. You know, this particular group, the COO. I didn't draw it properly because it just like, that's how it is.
I think what makes it tricky is you see that O between the 2 carbons.
Yeah,
But
I know. I
it's-
remember as a student, it was hard. I remember. I absolutely agree with you. Okay. So we have to, and you know, guys, what is the best part of this course is that this seems tricky and then everything else will seem so much easier to you. Only the first chapter seems like, wow, this is hard. Is it going to be like this? No, not at all. It gets much easier than after that. Once you learn all the names, it's easy. So what is CH3? Methyl. And what is 2 C's? That is something to do with eth, right? And so I'm going to give you a clue. It should end with OH. OH is the suffix, not by itself. It won't stay by itself, but the OH is the suffix. So it's going to be, this is the methyl part. So you have to say methyl. And then what is the second part?
suffix.
Do you see how I did that? Hmm. Okay, next one is really easy. Why don't we do the next
Still
one?
confusing.
Too confusing. This one, methyl ethanoate.
So you
Yes.
keep it apart
Why
like that?
don't, sorry, go.
So, uh, so the methyl ethanate, do you combine those words or you keep them spaced like that?
Space like
Okay.
that. Yeah, Teja, I was thinking maybe a good thing is that we learn other functional groups and then this one we kind of keep it towards the end. Like, don't worry about this right now. Rather worry overall about how to do this, then you won't have to, it won't be like stressful. I don't want you to be stressed out about this because this is not the only thing. This is just one part of all the things that we are learning. Okay, let's try that. Okay, let's leave this for now. Do the next one.
The next one would be methamine.
Yeah, that's fine. Okay.
The methylamine.
Methylamine, actually. I don't want to say that. I'm so scared. I don't want to confuse you guys any further. Okay, then this one. Okay, we can leave this one for now because this one would confuse you. Okay, so essentially what I want to say to you is that I had one more worksheet, but I'm not sure if you have the energy to do it. I mean, I have the energy to stay on, but the question is, you also should have the energy to work on it. And maybe that's what we should have done before. I'm going to share it with you and you can see if you want to do it or not. You know, I mean, of course you have the liberty to leave the class at any time. But when you are given the formula like this, wait a minute. Can you tell like what is the name? C3H8. Can you draw it? Can you draw it?
Yes.
Yeah, I can draw that.
You
Yes.
can draw that? Okay, try it. Because it may or may not have double bonds. That is the thing. You can name this molecule, right? This molecule is easy for you. Oh, no, let's not do that. Let's just focus on this part, C3H8. What would be the name of C3H8?
Propane, is it?
Okay. I'll try to draw it with you.
With the fire is painting.
Yeah, try to draw it and see but it has less number of H. That means it might need a double bond. One, two, for everyone's benefit, I'm just drawing here. Okay, C3H8, that does make a propane. So that's C5H8. So 1, 2, 3, 4, 5. Okay. Now I've only I can put only 8H. Okay. So which means that I'm going to put at least, I have put 3 here. That is 6. And if I have the liberty only to put 2 more, then I will be forced to make triple bond. So I'm going to make 1 bond over here. Now if I do that, this has 4, this has 4, this has 4, this is 4, this is 4. Did you get a similar structure like what I drew?
No,
Question, Professor. So can we distribute the hydrogen and still have double bond?
Yeah, you can do that.
Okay.
Also, you can do these at home and just, you know, like I'll share this with you and you can just share your, like take a picture and send it to me and I can check it for you and see where you know, where everything is going, you know, how everything is going for you. So you don't have to do it like all of it right now. You can just try some. Also, if I tell you like draw the structure of propene or pentane or octane, can you do it? Okay, let me see what's the chat. Oh yeah, absolutely. Yeah, I'm going to share whatever I have on the Canvas for sure. And you know, I'll have to make sure that the practice problems are also appropriate for you so that you don't feel overwhelmed. And before you submit your assignment, we will have another chance to meet because I'm making sure that all the deadlines are after we meet. So quiz and assignment deadline essentially will be moved to Sunday night for all of the quizzes and assignments. So if you work on your assignments and you find something problematic, let me know. I can tell you one of the problems that was tricky, which Teja, I think, pointed out, and others pointed out too, like about this particular molecule that is given in the assignment and you're supposed to find functional groups. That may seem like really confusing to begin with, but my suggestion is go back to your suffix table and see if you can find any group that resembles that particular group, like functional group, which is shown in the figure. So try to compare them and see. And you might come up with one or two names, and that's all I need. I don't need you to be too like, I just wanted you to be able to identify functional groups in that question number 7, I believe, 7 or I can't remember what's that question, 7 or 8, something like that. There is a drug for Alzheimer's. This is the structure of the drug. Identify the functional groups. All you need to do is match with the functional group chart and see if it is matching or not. So I'm going to stop sharing. I want to get a sense. I feel like there are still some challenges in the sense like some people, I mean, first of all, or let me put it the other way. I want to ask you, like, was this any helpful and any better than help you improve enhance your understanding?
Yes, I feel like I was able, seeing on different programs, like I was able to understand I mean, I don't understand the first 3 different bonds, but then I see Y, like the last one you say, and I know that Y stands for 3, so it's a triple bond, and the octo is for 8, so that already give me like 2 numbers. I just like feel like I still need to get it together. Like,
good point. Yeah, good point. And I think some of you stated that when the O comes in between and you have to do this methyl ethanoate or something methyl ethyl ether, those ones are the ones that are most confusing at this point. So
also the
like do those towards the end. You know, first let's go with alcohols and with you know, with the acids and aldehydes and ketones. Let's finish all of those first, and then do those in the end. How about that? I mean, I used to do that as a student. That's what I did, and it kind of worked out. So. Anything else? Like, I hope I know Valerie shared it. Anyone else, like, did it share to kind of review this information one more time? And I hope it did.
Yes, it helped a lot. It helped me a lot.
Okay. All right, good to know.
It helped me a lot too. I just gotta do more examples like practice at home. I just feel like when we're going over everything, I'm fine. As soon as I try to take my own little note, I miss a step and then I get lost again.
Okay. Did anyone hear the lecture at all? Like, did that help or no? Can't hear the lecture.
Yeah.
Okay. I mean, you can go back and listen to the lectures, and I'll put this one too. Just that takes like an hour for YouTube to update and put everything. But I'll put this one as well because others requested. Also, I wanted to say that if on a certain day I'm available for, I want to put this out while we have office hours. Like, if on a certain day I'm available for 30 or 40 minutes, I'll put this in GroupMe. Please don't feel pressure to come. If you are available and you can come, just come. Because there are sometimes I don't know my routine. I'm working, like I work at NIH 9 Monday through Friday, but on some days, if there is any kind of availability, I would let you guys know on GroupMe. That's why it's so important to join GroupMe. Okay, I would let you know like right away that I'm available today from this to this time. You guys, anyone has questions, so trying to answer that. Like I totally get it. Like, you know, sometimes you understand everything and then you go back and you're like, I think I got it then, but I don't quite get it now. So anything like that. Similarly, you can do the same thing. You can say, hey, I have a quick question. So you can say, Dr. M, I just need about 10 minutes. So if I know that I have the reference, oh, I guess this person needs a quick question for 10 minutes. And while I'm having lunch, I would be like, let me take out 10 minutes and explain it to you. We can just kind of work it out that way.
Professor, can you also share your office hours or the day you're gonna be like in a step, or just text me through Canvas too, because I'm out of the country, so I don't have access to that.
I always share everything in GroupMe is always on Canvas.
Okay, thank you.
Every single thing. And it goes in 2 ways on Canvas. One is announcement and second is individual mails, because people may not check announcement. So individual mail everyone. Everyone should have received a mail in the morning saying, today we have office hours this to this time. I did that, but I don't know if you got it. So from my side, I did share that I am available. And, I mean, today from this to this time. And,
thank you.
And we will have more availability as the time goes by. Just takes a week or two to settle down. So time is right now 4, and I know we have taken a lot of time, and I know that you guys have many other things to do. So I'm still here. So if you have any questions, feel free to hang on and ask questions, specific questions. And if you feel like, okay, you're done for now, please feel free to leave. Any other questions? Or...
So we can leave now?
Yeah, you can if you wish to, or if you have any specific questions, like I don't understand this particular question or this particular thing, or I want to share this experience, then please hang on. And you can always also private message me if you're kind of tired waiting for your turn.
Thank you.
All right. Have a nice time, everyone, who's ever is leaving.
I had a quick question.
Yes.
I already submitted my assignment and then we went over stuff today. Is it okay if I like resubmit it because you didn't? Okay.
Totally okay. Resubmit how many ever times till the deadline. No, doesn't matter for me.
Okay, thank you.
Yeah, you went over things and then you feel more confident about something, do it again.
Okay.
Question, is there there's an array of them listed in the modular, but one of the slides shows 1, 2, 3, 6, 7 functional groups. Should we just focus on those 7 or all of the ones?
That is a good question. I was hoping I covered everything in that, but maybe I have not. Yeah, I think I have missed out 1 or 2. All of them. I will make sure that list is complete and re-update and put it. Thank you for bringing it to my attention.
Because there's a slide for classifying.
Yeah, I know. I should include all of them. I will do that.
Okay.
Anyone else with anything? And like I said, you can also put on the chat. I want to stop recording now.